Hello class, today we're going to go ahead and start section 3.4, linear programming. So this is our last section in chapter 3, so get ready for that chapter 3 test. Our learning objective for today is that you'll be able to create and analyze a linear programming model. So linear programming, what is it? Many real-life problems involve a process called optimization. So finding a maximum or minimum for something. For example, a company may want to maximize profits. We will learn to find minimums and maximum using a process called linear programming. Okay, so linear programming model, it consists of a system of constraints. So it would be your inequalities. It's going to be a system of inequalities. And an objective function that can be maximized or minimized. So the objective function is what you actually want to maximize or minimize. So if you want to maximize profit, it's going to be a function to do that. So, solving a linear programming problem, you want to find the minimum or maximum value of an objective function. So what you need to do is you need to graph the constraints, find the vertices of the graph of the constraint systems. So if you look over here, the shaded area is my feasible region. Excuse me. So that is what you want to find the vertices of. So you want to find this vertice and this vertice and this vertice. That's what they're talking about for step 2. And then 3, you want to evaluate the objective quantity at each vertex. The least of these values is the minimum, and the greatest of the values is the maximum, if there is a minimum and a maximum. So let's go ahead and just look at an example where we go ahead and do this. So what we want to do is graph the following system of inequalities, name the coordinates of the vertices of the feasible region. So remember that feasible region is that shaded in region, and then find the maximum and minimum values of a function for this region. Okay, so our objective function, we do not graph that. We use that to maximize or minimize. Okay, so that's what that is used for. Do not graph it. We just go ahead and graph our constraints. Okay, well, our first constraint is x is greater than or equal to 1. I'm going to go ahead and do that in green. It is a solid function, solid line, excuse me, and x equals, well, that is a vertical line. So, where x is equal to 1, so straight up and down. And it says x is greater than 1, so I want to go ahead and shade to the right of 1. You can shade all of it, but it might get kind of messy, so I just do a few arrows to show which way I want to shade. The next one is y is greater than or equal to 0. I'm going to do that one in blue, and once again, since it's equal, it's going to be a solid line. Y equals is a horizontal line. Okay. It says y is greater, so once again, I want to shade above. Looking at my arrows, I can see that that top right square would be where I would have everything shaded. And lastly, I want to go ahead and graph 2x plus y is less than 6. So I'm going to solve this one for y as the main variable. So I would subtract 2x. Y is less than or equal to negative 2x plus 6. I'm going to do it in red. So I start with my y-intercept of 6. And my slope is negative 2, so it would be negative 2 over 1. So down 2 to the right 1, down 2 to the right 1. And this is also going to be a solid line because it is equal to. Now, as you can see, it's y is less than, so I would shade below the line, so I'm going to be shading this way. So this would be my feasible region. Now what we need to do is we need to go ahead and find the vertices of that feasible region. So we're just going to call them x and y, ordered pairs. So I would say we have the point 1, 0, we have the point 3, 0, and we have the point 1, 4. Now what we need to do is plug that into our objective function. That is our f of x and y. And it's 3x plus y. So I plug in my values. So it's 3 times, well, my x value is 1, plus y, which in this order pair is 0. 3 times 1 is 3, plus 0 is 3. Then I would go ahead and do the next point. 3 is my x, and 0 is my y. That one gives me 9. And the last one, I plug in 1 for x and 4 for y. 3 plus 4 gives me 7. Now it tells me to find the maximum and minimum values. Well, my maximum would be 9. So it is when my x is 3 and my y is 0. My minimum is when x is 1, when I reach all those constraints. Okay, let's go ahead and look at the next one. I would like for you to graph this one on your own, so please pause the video and do this one on your own. Here's the solution for example 2. One thing I want you to notice is that one of the points at the very top here does not fit on the graph, but you know which point it is if you follow along with your slope. So you should get that 8 is the max and negative 20 is the min. Now let's go ahead and just look at the steps to do linear programming. First, you want to define the variables. So I want you to tell me what x represents, what y represents. 2, I want you to write a system of inequalities. 3, you graph it. Okay. 4, you find the vertices of the feasible region, just like we did on the page before. 5, you write the linear function to be maximized or minimized. 6, you substitute the coordinates of the vertices into the function, and then lastly, you select the greatest or least result to answer the problem, depending on what the problem is asking for. So let's just go ahead and look at an example and follow through all of these steps. Okay. Example 3, as a receptionist for a veterinarian, one of Dolores' tasks is to schedule appointments. She allots 20 minutes, 20 minutes for routine office visits and 40 minutes for a surgery. The veterinarian cannot do more than 6 surgeries in a day. The office has 7 hours available for appointments. If an office visit costs $55 and most surgeries cost $125, how can she maximize the income for the day? Okay, so the first thing we need to do is define our variables. So I think to myself, what are the 2 things that I am talking about? Well, I am talking about office visits and surgeries. So I will let x equal the number of office visits. And then I'm going to let y equal the number of surgeries. Okay. Step 2, we need to go ahead and write a system of inequalities. Okay. We are trying to maximize profit. So we are going to leave anything that deals with making money till we get to our step 5 to write a function to be maximized or minimized. So we need to write, we're going to leave out money. So what I would think is my minutes. They all kind of go together. So here is time, and here is time, and here is time. But then I notice, oh no, it's 7 hours. So I need to change that into minutes. So I have 7 hours times, well, how many minutes are in an hour? 60. So this is going to give me 420 minutes. So I'm going to use that fact. So it's 20 minutes for an office visit. So 20 times x, plus it's 40 minutes times a surgery. And I cannot do, they have 7 hours available for appointments, so they cannot do more than 7 hours. So this must be less than or equal to 420 minutes. Okay, the next thing that says is the veterinarian cannot do more than 6 surgeries. So my surgeries is y. It can't be greater than, so it has to be less than or equal to 6. And then there's 2 constraints that are pretty easy to forget about, but they're important to include, is that you can't do negative surgeries or negative office visits. So my office visits have to be greater than or equal to 0, and my surgeries have to be greater than or equal to 0. Okay. Step 3 then, we need to go ahead and graph the system of inequalities. I would, first of all, maybe for this one, the top one, find the intercepts. Okay. Or you can solve it for y equals. It's up to you. We are going to find, I'm going to find the intercept. So when x is 0, if you plug in 0 for x and you divide by 40, you get 10.5. And when y is 0, plug in 0 for y, so 420 divided by 20 will give us 21. So I'm going to use those 2 numbers to graph this top equation here, and I'm going to do it in green. I guess before I do that, I need to go ahead and put a scale on here. So these are by 5. So 5, 10. Same thing on the horizontal. All right, now I'm going to go ahead and graph that top equation. So I have the intercept 0, 10.5, and I have the point 21, 0. I would highly recommend using a ruler for something like this. Okay. So there's that one. It is currently in black. So that's for the top one. Now let's go ahead and graph y is less than or equal to 6. Oh, first of all, we should talk about this one. I would be shading below. And if you're not sure why, I would check the point 0, 0. If I plug 0, 0 in here, then I would go ahead and I would have 0 is less than or equal to 420, which is true. That's why I'm shading where the point 0, 0 is. Now I have y is less than or equal to 6. So I will do that in blue, and that is a horizontal line. So where y is 6. And it says less than, so I'm shading below. So I'm getting this area here. And then the last two are my constraints. Well, x is greater than or equal to 0 is a vertical line. So to be greater than, we're in this area. And also my y is greater than or equal to 0. That would be this line as well. Okay. I would like for you, step 4, to find the coordinates of the feasible region. Okay. I would like for you to do that on your own. And then we will pick up and finish with 5, 6, and 7 tomorrow in class. So go ahead and find the coordinates. They're already listed there for you. They're the ones that I just am putting here on red. So just list those, and then we'll go ahead and finish up tomorrow. Have a good day, and I will see you tomorrow.